up, my 8th grade class? Welcome to the 20th day of your online curriculum. Congratulations. We've hit double tens. So today we are going to be talking about something called the unit rate. And one way to find the unit rate is through division. So let's say I have 28 apples, right? Because that's what math always uses is apples. And for the entire 28 apples, it costs $7, okay? So the unit rate is multi-directional, right? You could either find how many apples are in $1, or you could go the other direction and find how much does one apple cost, right? So either way we're gonna do this is we're gonna do a division. So if we wanna find how many per dollar, we're going to divide by the 7. So we divide by $7 and we get 4 apples per dollar. Right? 4 apples per dollar if we go that way. If we go the other direction, we're going to take $7 and divide it by 28, right? And Mr. Cartwright's going to get a calculator as I gave myself a problem that I don't know how to do. So $7 divided by 28 is going to give us a number, and that will be 25 cents. I feel like I could have actually done that in my head without the calculator. But yes, so an apple costs 25 cents, and you can get 4 apples for $1. So that makes sense. The unit rate is one of our ratios, right? Or a proportion, right? You see what we made here? We made a fraction. Whenever we're making a fraction, proportion, right? These things are all similar to each other. Okay, moving on. The rate of change is our first introduction to the concept of slope. So let's say I'm going 2 miles per hour. Right? That's how fast Mr. Cartwright can run. He's super fast. But you can see how 2 miles per hour is a unit rate, right? You have 2 miles for every hour that occurs. The rate of change refers to this over time. So we can apply the rate of change to multiple hours. So how long have I gone in 10 hours, right? We apply our rate of change times 10, and we get 20 miles, right? So in 10 hours, I've gone 20 miles. Rate of change and unit rate are practically the same thing, right? We're taking how far it goes up or down and putting over how far it goes left or right. Which brings us to the big concept of this unit is slope. So let's say we have a line, right? There's a line. One of the goals of 8th grade is for you to be able to write an equation for that line, write an equation for a linear pattern. So let's start with the slope. There are going to be 2 things you need to figure out when you're writing a line. One is the slope of that line, and the second one is where it crosses the y-axis. So it crosses right there, but let's figure out the slope first. What is slope? Slope is the rate of change, right? How fast something is going up, how fast something is going down. Slope can also be considered the unit rate. Slope is also a proportion, right? It has a fraction, right? And so whenever we have a PB, right, we're going to create a fraction. And in this case, the fraction is related to how far it goes up, which goes on top. And we're going to represent that in purple. So let's say there's a point right here, and this is how far it goes up. That goes on top. So up or down goes on top, and left and right goes on bottom. Let's use a different color for that. Let's use yellow. So what we would do to calculate the slope of a line is we would find 2 points on that line, right? So we'd find a point where usually it's a whole number, right? I want to use that point right there because it's a whole number. And I'm going to use that point up here at the top too, right? I'm going to take my purple value, however much it goes up, and put it on top of my fraction. And I'm going to take my yellow value, how much it goes left or right, and put it on the bottom of the fraction, right? So up and down goes on top, left and right goes on bottom. That is how you would write or find the slope, right? You count how much it goes up to the next point, count how much it goes over. For instance, if this is 5, right, and 8, our slope would be 5 over 8 in this case. One thing to note is if the line is going up, it's positive, and if the line is going down, like it is over here, it will have a negative slope. Negative rate of change, negative unit rate if it's going down. All right, last thing I wanted to talk about today was plotting points. So whenever we're given a table, right, like let's say 2, 10, 5, 4, 3, -3, -4. All right, we have points in a table in an X and Y grid. We have our X's are always going to be on our left, and our Y's are always going to be on our right. Our X's are where I always like to start. That tells you which way we're going. Right, this way is always going to be positive. And left, the other direction, is always going to be negative, okay? And that's always going to be the first value you get. So let's plot that 2, 10. So we go over 1, 2, right? And now Y values, these ones over here are going to tell us how much we go up or down. So in this case, we went over 2, and we're going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2, 10 would be like right there. 5, 4, we're going to go over 5 first. 1, 2, 3, 4, 5. Right there. And then we're going to go up to the 4th value. So over 5, whoops, and up 4. Always remember, left is negative, so let's do that last one. -3 would be this way. 1, 2, 3, -3 right there. And -4 would be down. So our next point would be right there, right? So X values tell you left or right. Y values tell you up or down, okay? So hopefully that all made sense to you guys. Congratulations, you beat a coronavirus. Now, how long will it take for you to beat them all? Just when you thought the math lesson was over, we come back with more math. So using scientific notation will help us solve this problem, right? If Mr. Current was able to defeat one coronavirus particle in 45 seconds, yeah, that's not true. It's not how viruses are destroyed. Anyways, in a single cell, when a single cell explodes and releases all of its virus particles to the rest of the body, there are about 700 viral particles released in one cell. There are about 3 trillion cells in your body. So 3 times 10 to the 13th would be that number. So to figure out how many viral particles are released in one person, we have 7 times 10 to the second power times 3 times 10 to the third. Using scientific notation, we multiply the first two guys together, we get 21 times 10, and then we would add these two to get 10 to the 15th. So 21 times 10 to the 15th. Then we need to account for all of the people who already have coronavirus in the US, which is about 7 million. So we do 7 million times 21 times 10 to the 15th. 7 times 21 is 147. Times 10 to the 6, we add those two together to get times 10 to the 21st. So the current viral load of the US right now is about 147 times 10 to the 21st. And if Mr. Cartwright defeats every one of those every 45 seconds, hold on for some intense math calculation. We are left with, it would take Mr. Cartwright 6 quadrillion years to single-handedly take apart each viral particle in the United States of America. So I think you're going to need some help, Mr. Cartwright.